Good to see you here, my curious friend. Like me, are you also fascinated by these incredible inventions? So, welcome to How Stuff Works, where we explore the fascinating world of technology and science, breaking down how things really work. In today's video, we're uncovering the secrets behind those massive wind turbines you often see out in fields and oceans. Ever wondered why they have 3 blades or why they're built at that specific size? Stick around, and you'll easily understand the logic behind it all. Why do wind turbines have 3 blades and their specific size? When we look at wind turbines in wind farms, they always seem to have just 3 blades, and sometimes they appear smaller than we'd expect. But why do they have only 3 blades? Wouldn't they generate more energy if they were bigger or had more blades? Today, I'll explain why turbines are typically built with 3 blades and how their size is optimized. The history of harnessing wind power. Humans have been using wind power for thousands of years. The earliest recorded use dates back over 1,000 years in Persia, where windmills were first utilized. These early machines were quite different from modern wind turbines and were used mainly for grinding grain and pumping water. Over time, technology advanced, leading to the massive wind turbines we see today, capable of generating enough electricity to power entire cities. Although various turbine designs have been tried throughout history, the 3-blade design is now the most common. But why 3? Why 3 blades instead of more? Think of a turbine blade like a wrench turning a bolt. The longer the wrench, the more torque, or turning power, you can apply. If you add another wrench, you can generate even more torque. The same principle applies to turbine blades. Adding more blades seems like it would generate more power, right? However, the number of blades directly affects several factors, including efficiency, cost, and the structural integrity of the turbine. The largest turbine example. The largest wind turbine to date is the Mingyang Smart Energy, with a massive 260-meter rotor diameter. Each of its 3 blades is 123 meters long, and even though they are made from lightweight materials like carbon fiber, each blade still weighs around 54 tons. The tips of these blades can reach speeds of up to 70% of the speed of sound. So, adding more blades would increase weight. What would that mean for the turbine? Comparing 2-blade and 4-blade designs. A 4-blade design could significantly increase the cost of building a turbine without a proportional increase in energy generation. And why not use 2 blades? While 2-blade turbines could spin faster, this would also create additional issues like vibration, centripetal force, and noise. The material used to build the 3-blade wind turbine blade was calculated for the blade to resist up to a specific speed and a maximum vibration exerted on it. When using this same blade to assemble a wind turbine of just 2 blades, we would notice that the blades would not resist the effect of a speed above that which was designed, and equally, a greater vibration on them. Besides, the centripetal force, the force that pulls the blades towards the center as they rotate, is greater in the 2-pass wind turbine, due to the greater speed at which they rotate. So, investments would be needed to reinforce the blades to be resistant to these higher speeds and vibrations. And also, to reinforce the structural components to resist greater centripetal force. One notable concern is noise. A 2-blade turbine, because it spins faster, tends to be noisier. This can be a big issue for people living near wind farms. The 3-blade design allows for slower, quieter rotation while also being more efficient in capturing wind energy steadily. Why don't turbines just keep getting bigger? You might wonder why we don't just make turbines even larger to generate more power. The size of the blades is carefully engineered to capture as much wind as possible without putting too much strain on the turbine structure. If the blades were too large, the extra weight would require stronger towers and more expensive foundations, significantly raising construction and maintenance costs. Additionally, the blades must be light enough to maintain efficiency but strong enough to withstand high winds and pressure. What can we conclude from this? The 3-blade wind turbine design is no coincidence. It balances factors like cost, durability, and energy production efficiency while minimizing problems like vibration and noise. The size of modern turbines is also calculated to capture as much energy as possible without overwhelming the structure. This is why the wind turbines we see today have 3 blades and a size that, although impressive, is optimized to capture wind energy efficiently and economically. Thanks for watching. If you found this video helpful or learned something new about wind turbines, don't forget to give it a thumbs up. And if you're curious about how other things work, make sure to subscribe to the channel so you don't miss out on future videos. Your support helps us keep bringing you more exciting content. See you in the next video.